Hi there, so today we are going to have a look at some past paper questions and then you guys are going to go and do some on your own. You obviously will, as usual, be able to ask your teachers if you get stuck, but hopefully these will help you maybe see some different ways of doing it in terms of like what the question's asking. The thing with enthalpy of combustion is there's only so many things that they can ask. So what they will tend to do is they might play around with what they're asking you to do and what they're asking you to calculate. But at the end of the day, it's always going to be something to do with a molar ratio and how much energy that gives out, and the equation E equals Cm delta T. So with that in mind, let's start this one. So we've got an enthalpy of combustion given to us, and we are to calculate the number of moles of ethanol that we would need to require to raise the temperature from 18 degrees Celsius to 100 using 500 grams of water. So what we're going to do is we're going to start with our favourite equation, which is E equals Cm delta T. We're going to just work out the energy that we would require for that change. So we're going to use 4.18. It also mentions 500 grams of water, which we know we need to change into kilograms. So it's going to go from 500 grams to 0.5. And we're also going to use the change in temperature. And the difference between 18 and 100 is going to be 82 degrees Celsius. When we put that into our calculator, we are going to get 171.38 kilojoules. And as always, we know that this is going to be negative because combustion reactions are always exothermic, which means they lose energy, and give that into the water. So there we go. That's us done our first part of this equation, this question. We now need to use our proportion to work out the number of moles that we would require to do this energy change. So what I'm going to do is it tells us in the question that the enthalpy of combustion, so the actual for 1 mole, is going to be 1,367 kilojoules. And that would be from 1 mole. We only need 171.38 kilojoules. So how many moles is that going to be? Let's calculate it. We are going to do our proportion again. This is going to be new, this is going to be old, and this is going to be other side. So if we put that into our equation, that would be 171.38 divided by 1,367 times by that 1 mole. If we do this in the calculator, remember we know that we want to do this first, and then obviously if you're times at 1, it doesn't matter for this one. So we're going to end up with this being 0.125 times by 1, so it's just the same. It's going to be 0.125 moles. And that is the answer there. So again, it's pretty simple. We know how to do that. It's just the proportion thing that might be a wee bit tricky. I'm also going to go for the guys that are liking this cross multiplication. I'm going to do that for them as well. So what you'll have is you'll have 1,367 kilojoules divided by 171. That's going to be 1 mole, and we don't know that one. Our x moles then, or our x is going to be 1 times 171.38 divided by 1,367. And what happens is if you put those kilojoules in there, they actually cancel out anyway, and you're left with that mole. So what is going to happen is you're going to have these numbers working out, and it will give you the same as what we've had before. Oops. not sure what happened there. And that's going to be 0.125 moles. There we go. So hopefully you're feeling happy about that. That's making sense for you. Again, it's just the proportion, and I think that is probably the hardest bit of these, because the National 5 part is pretty simple. We should be quite happy with that. It's just the proportion bit that I think can be sometimes a wee bit tricky to get your head around. But you've got two ways of doing that there. You've got your proportion, new overall times the other side, like doing it like a linear scale factor if you want to think about it like that, or you can cross multiply if that is what you prefer. We've got the second part to this question, and usually when these are asked in exams, the two go hand in hand. It's asking to suggest 2 reasons why less energy is obtained from burning ethanol in the camping stove than is predicted from its enthalpy of combustion. Well, there's our 2 wee things that we spoke about a few times now. Obviously, there could be incomplete combustion. Or the other thing, which is heat lost to the surroundings. There we go. That's a pretty standard answer for anything that's asking about why the energy is less or why it's different from what you would expect or what is predicted. So maybe it would be a good idea to learn these. We're going to try another example now, and it's finding that the student found that burning 0.370 grams of methanol produces 3.86 kilojoules of energy. Now this is nice because you don't actually have to do the EH equals Cm delta T. E equals Cm delta T. So we don't have to do the first step, we just have to do the proportion part. So let's do this together. It's obviously talking about methanol, which is CH3OH, and we know that's got 1 times 12 grams, 3 times 1, 1 times 16, and 1 times 1. So that all adds up to 32 grams. So let's do the proportion. They already know that 0.370 grams would produce 3.86 kilojoules. And that's obviously going to be negative as well because it is exothermic. What we need to do now is we need to work out the mass of 1 mole, which we've just done. So 1 mole is 32 grams. With that in mind, let's use the proportion to work out the amount of energy that would be produced with 1 mole, and that is also the enthalpy of combustion for this methanol. So, with this in mind, let's look at this. So we'll do a simple proportion. We're going to do new over old times other side. And that is going to be 1 divided by 0.37 times by 3.86. We'll add a negative in at the end. Because that's the T00. Oops, made a wee mistake. I'm just going to change this. This should be 32. Because it's the mass, not the moles. So that's fine. That simplifies out, if you did this part, the first part in your calculator, that comes out to be 86.486 times by 3.86. So that your final answer is going to be 333.84 kilojoules per mole. And remember that you need to put this per mole part in because it's the enthalpy, and remember we need to always put the negative in because we know that this is a combustion reaction, so it's going to be negative, it's going to be exothermic. I'm just going to do this again for the people that are enjoying the cross multiplication in case that is something you want to see here. We'll set this up just the same as we've been doing before. So we had 0.370 divided by 32, and that would give us 3.86 divided by x. So to find x, we're going to rearrange these, and that's going to be 3.86 times by 32 divided by 0.37, and that should work out to be 333.84. Remember that this is exothermic kilojoules per mole. That should be a big, there we go. Perfect. Hopefully that has allowed you to see that these are different ways of doing some past paper questions. It's maybe showing you different ways you might be asked, and also it's letting us see this incomplete combustion and heat energy loss to the surroundings as well. It's fine. So as before, if you get stuck or there's anything you want to ask, feel free to get in touch with your teacher. Next time we are going to be looking at something else. It's a different enthalpy. It's going to be the enthalpy of solution. So we've got that to look forward to.